What are waves is a common question for a person to be asking in physics. To put it simply, waves are vibrations in matter caused by a moving object. These waves can come in different forms. Waves are categorized into 3 distinct types: mechanical, electromagnetic, and matter waves. Starting with mechanical waves, these are waves created by oscillating matter in which it transfers energy throughout a medium. There are 2 types of mechanical waves. Transverse waves are perpendicular to the direction of energy, depicted as your usual model of a wave, an up and down motion if you will. Examples of this are sound and pressure waves. Longitudinal waves are parallel to the direction of energy. Think of a slinky when you move it back and forth. An example of this is light. Surface waves are a combination of both transverse and longitudinal waves, commonly found in earthquakes. Electromagnetic waves or electromagnetic radiation, however, are created by electric and magnetic fields. Electromagnetic radiation. These are waves that don't need a medium to travel through. It also doesn't require a physical medium to be created. Some examples of this are microwaves, X-rays, radio waves, ultraviolet waves, and light itself. I am not, or I don't think I am, required to cover matter waves, but I'll put it here because I want those extra points. Give me an A+, Mr. R. Anyways, matter waves is a complicated concept to tackle. It's defined as the dual nature of light. It's the concept that light can act as both a particle and a wave. This is interchangeable based on what you're trying to measure.
Now that you know what waves are, you also need to understand the math behind it. Using my lasso as an example, this is 1 cycle. The amount of times a wave passes through this marker in 1 second is called frequency. And the amount of time it takes for 1 cycle to pass through is called the period. Both the frequency and the period of a wave are inversely related, which means this equation for frequency, F equals 1 over t, can also be switched around to be the equation for period, t equals 1 over f. This also means that if the frequency increases, the period decreases, since it's an inverse, and vice versa.
With the math out of the way, let's do an example. If I put this laser through this glass, you can see that it passes through it at an angle. This is due to refraction, the change of medium from air to glass. The glass slows down the waves, causing the wave to appear bent.
And with that, you can also say the same thing the reverse way. The more bent the light appears, the slower the wave travels through the medium.
The more bent, the more indices the angle of the wave is.
Let's do another example. Let's say this lantern light hits a river's surface. The light waves will not only reflect off the water, but it will also be absorbed, refracted, and transmitted by it, mainly due to it being a transparent, smooth, and shiny medium. Even in the lantern itself, when the light passes through the glass, it is being refracted to shine the area around it. Now, the same setup happens with cloth, but it will only absorb. In this absorption, the waves are translated into thermal energy, also known as heat. This is most apparent when you are wearing dark-colored clothing.
Is it getting hot in here, or...?
And with white-colored clothing, not only does it absorb less waves, but it also reflects the waves. Which is why white clothing keeps you cooler than black clothing. With both of these examples, the new medium is slowing down or even absorbing the waves, causing the light waves to change.
Now, there is this phenomenon where waves can interfere with each other. This is called superposition, the result with waves adding to each other. Here in this pond, we have 2 ripples, or waves, that will collide. When it collides, you can notice that some spots are missing. These are the waves interfering. It's most noticeable when it's a rope, so I want to just borrow this real quick. These are 2 waves heading towards each other. Since they are both positive in value, they will add up and create a bigger wave. The sum of these 2 values, 2 and 3, add up to the value of 5 in the superposition wave. This is called a constructive wave or constructive interference. Now, look at these waves. One is negative and the other is positive. When they combine, the sum total, 2 and -1, combine to make a smaller value than both values before, resulting in the superposition wave being smaller. This is called a destructive wave or destructive interference.
Now, going back to the aforementioned concept of the dual nature of light or matter waves, electromagnetic waves can also be described as this as well, the wave-particle duality. And for the sake of my sanity and trying not to animate a 10-minute video, I'm only going to explain how electromagnetic radiation can be a particle. This dives into the quantum or atomic level, so stay with me here, all right? Let's say Veronica produces a light ray that is so fast and full of energy that it bumps an electron up a level, in which promptly the electron loses this energy and gets knocked back down, resulting in a release of energy. This energy is called radiation, and this is called the photoelectric effect. The radiation produced by this is called ultraviolet light or UV light. This is proof that EM waves can also be particles. One reminder of this is our sun, which produces a constant stream of UV radiation, so make sure to put on a hat.
On the topic of EM waves, digital transmission is one of the biggest revolutionary ideas we've ever had. Not only is digital transmission faster than analog, it can also store more in less space. Kind of like comparing a 5 gigabyte floppy disk with a 20 gigabyte USB. Smaller, but stores more. Digital transmission can also travel more distance without ruining its quality, while analog signals, such as radio stations, do. Think of yourself driving deep in a forest with the radio on. The static is you losing quality and the actual interference of analog signals from the radio stations. Also, you can copy digital stuff without losing quality, while in analog, you can.
It is no doubt that waves are important. This is apparent as it is in our everyday lives. We use radio waves for communication, light waves for tech to display images, microwaves to heat things, and X-rays for skeletal scans. We have managed to use the behavior of waves to our advantage in technology.
It's being refracted to shine the light rays in the area around it. Oh my god.
This is the most noticeable when it's a rope, so let me just borrow this real quick. Why is the AI freaking out? What